Today's lesson is a continuation on our writing linear equations unit that we started 2 days ago. And we're looking at writing equations of parallel and perpendicular lines. And so we have a couple of examples here. I assume we all know what parallel and perpendicular are. So let's go ahead and get started. As far as writing equations are concerned, we think of parallel lines as lines that have the same slope, and you're often taught the definition parallel lines are lines that never intersect, and that's true, and the reason why they never intersect is because they grow at a constant rate that is the same, and that would mean they have the same slope. So if we look at an example here, if we want to write the equation of the line parallel to y equals negative 2x plus 5 going through the point negative 4, 9. So in order to go about solving a problem such as this, we have to first recognize what we have in the problem. We have a line we're parallel to and a point. Now yesterday we learned the point slope formula, and so if we had a point and a slope, this would be easy. Well, when we look at our first line and we realize that our lines are parallel, that means the slopes are the same. So that means we're going to take the slope from this first line, and that's the value here in front of the x, and remember, we only want the slope. We do not do anything with this 5. This 5 is actually worthless information to us. All we care about is the slope of the original line because we want to be parallel to that. So we steal its slope and use that in the point slope formula. And from yesterday, hopefully you remember our point slope formula is y minus y1 equals m times x minus x1, and we're ready to plug into that. Y minus 9, that's the y value in our point, equals negative 2. That's our slope that we stole from the other line because we know they're parallel. They must have the same slope. And our plus 4 comes from the negative 4 for our x value. Now, the rest of this is exactly like yesterday. We plug in, we distribute, and we solve, giving us our equation y equals negative 2x plus 1. That would be the equation of the line parallel to y equals negative 2x plus 5 going through the point negative 4, 9. Again, it's really important you understand when we're talking about the original line, the line we're trying to be parallel to, all we're concerned with is the slope. We steal the slope, use it to create our new line, because once we have a slope and a point, it's exactly what we did yesterday. Perpendicular lines are a little bit more complicated because lines that are perpendicular, they have to have slopes that are opposites of one another, because if one line's going up, the other line would have to go down in order to intersect at a 90-degree angle. So therefore their signs are always going to be opposite each other. That's why you see that it says lines that are perpendicular have slopes that are negative. The negative is telling us the sign will always be the opposite and they're reciprocals of one another. So therefore you're going to take your slope of your original line and you're going to flip it and change the sign. And again, just like our previous problems, all we're going to steal from the original equation will be the slope. So when we look here, first of all, an example of slope. If a line has a slope of 3/4, a line that would be perpendicular to that would have a slope of negative 4/3, because the 3/4 is positive. We do the negative reciprocal, so it becomes negative 4/3. If the original slope is negative, the perpendicular slope would be positive. So if we look at our example, give the equation of the line perpendicular to y equals 2x minus 5 going through the point negative 4, 7. Again, we've got a point and we can find our slope, so therefore we're going to use the point slope formula. We plug in y minus 7 equals, and then we see our negative 1/2 for our slope. If it's a whole number for a slope of 2, we assume that is 2/1. So therefore we flip it, giving us 1/2. And our original line had a positive slope, so our new line has to have a negative slope. So we get negative 1/2. And then we plug in the x plus 4 from our point. Now again, same as yesterday. We distribute, and we move the 7 over, giving us y equals negative 1/2 x plus 5. All right, that's it. If you're comfortable with what we did using point slope, all we're doing for parallel and perpendicular is taking the slope from a previous line and either copying it or changing it into its negative reciprocal and then doing what we did previously with the point slope formula.